cannot wait more than this time. Anyway, let us to go back to the to the last section where we stopped there, which is the modeling of the first order linear differential equation. And we had the first application that we had last time. It was the cooling and warming problem. And we said that according to the Newton law, the rate of at which the body change is proportional to the difference between the temperature of the body and the temperature of the surrounding media. We translated this one to the formula or the differential equation dt by dt equal k times T minus Tm. Tm is the temperature of the surrounding medium. الآن we had one example أخذنا المرة الماضية. Let us do the next examples inshallah ta'ala, and we will finish the application. We will start a little bit in chapter 3 today inshallah. Anyway, let us to see this example. The example says we have a metal bar at a temperature of 100 Celsius degrees is placed in a room at a constant of 0 Celsius degrees. First of all, when we say that, let us to translate a metal bar of 100. That means this means T of 0 is equal 100. A place in a room with constant temperature 0. This one here means that Tm is equal 0. After 20 minutes, the temperature of the bar is 50 degrees. This one implies T over 20 is equal 50. The question says find the time it will take the bar to reach the temperature of 25. The temperature of the bar after 10 minutes. Okay. First of all, when we write the differential equation of the model, we have d capital T by dt is equal a constant k times t times Tm. And when you substitute these given information, it becomes dt by t is equal k times T minus Tm, which is 0. So is equal k times T. Now this differential equation dt by dt is equal kt. It is linear. Becomes now dt by dt minus k phi t is equal 0, which is linear, where p of t equal minus k and f of t is equal 0. I mean linear differential equation. Now I need to solve it first. And to solve this differential equation, I need to find the mu of t, which is e to the power integral dt. Yes? Any question?
Okay, Professor, just to make sure, we are using Tm to model the room temperature, right? T is the temperature. Yeah.
Yes.
Tm is the room, right? And T is the temperature of the metal bar.
Tm, yep, yes, the room. Yes, of course, the surrounding medium here. So
okay,
it becomes e to the power integral k la dt, which is e minus t. هلا T of t 1 by mu times c plus integral mu times f with respect dt, which is equal e to the power kt times c plus integral mu times f of t. It is 0, which is becomes a constant c plus c also is a constant t. So constant c. So T of t, it is c e times to the power kt, k times t. And this is the solution of my differential equation. Before doing anything, I need to find out this constant c. How? I usually use the initial condition t of 0 is equal to 100. So 100 is equal CPE times K times 0. That means C is equal 100. And then TT now becomes 100 to the power KT. This is my differential equation. But before doing anything, I need to find out the constant, the coefficient or the proportional K. How? Use that T over 20 is equal 50. So 50 is equal 100 e to the power k times 20, which means minus 50 e to the power 20 k. No, 50 divided by 100, sorry, not minus, it is not positive. And I need to find k, take ln for both sides. So this one becomes 50 by 100, it is half, equal e to the power 20k. Therefore, take ln for both sides, 20k is equal ln of half, which implies k is equal ln of half divided by, which is minus 0.035. Now substitute there. So TT بدها تساوي عبارة عن 100 minus 0.035 times T. Now the first part of the question says find the time when it will reach 25. So I need the time t that 25 is equal 100 e minus 0.035 t, which means that 25 divided by 100 is equal e minus 0.035 t. And it's very simple that the t becomes 1 by minus 0.0 times ln of 1 by 4, with time بتساوي 39.6 minutes. Okay. Now second part, I need t of 10, which is very simple. Just substitute the time t 10 minutes. That becomes 100 e to the power minus 0.035 times 10. And you can just do this calculation, becomes 70.47 Celsius degrees. I'll just clear this example. واضح المثال هذا؟ Any question?
Professor, why did we multiply, in the last line when we did t of 0, sorry, t of 10, why we do 100 exponential to the power minus 0.035 multiplied by 10?
Because you just you need after 10 minutes. So this is the model here. Just substitute the time t, small t, is equal 10 minutes.
Thank you so much, sir. I'm sorry for asking such a stupid question. Thank you.
No, it's okay. It's all right. I have another application now which is very straightforward and very simple for you as an electrical engineering students. That's about the series circuits. And we will create a model for the series circuits. Of course, two types of the series circuits, and we will have some examples, inshallah ta'ala, two examples. This is also a very simple and straightforward application. Consider the single loop series circuits containing the inductor L. The voltage drop across the inductor is the voltage which is drop across the inductor is L times di by dt, where I of t here will denote the current in a circuit after switch is closed. Di by dt, L times di by dt. But I of t here, what does this mean? It denotes the current in a circuit after switch is closed. طيب. الآن a resistor R, a resistor of resistance R, the voltage drop across the resistor عبارة عن I times R. The capacitor or condenser of capacitance C, the voltage drop across the capacitor C is 1 by C times the QT, but the QT denotes what? The charge on a capacitor at a time t. طيب. الآن, according to Kirchhoff's second law, the increased voltage ET on a closed loop must equal the sum of the voltage drops in a loop. I mean, L times di by dt plus IC 1 by C times Q is equal E of t. طيب. الآن I is equal dq by dt here. Okay. We will go back and we will use this application later on, but we need to see the LR series circuit. الآن assumes that for a series only a resistor and inductor. Only resistor R and the inductor L. Kirchhoff second at L times di by dt plus Ri is equal Et, which is this one here. I mean, there is no, in this type of the series is, there is no type. So that differential equation here, this one will be reduced to this one in case capacitor. And this differential equation is linear equation for the current I. I mean, when you solve it, this differential equation, you will get I of t is called the response of the system. So this is the LR system. It has no capacitor, just only containing resistor and the inductor. طيب. الآن CR series circuits for which contains only a resistor R and a capacitor C. There is no inductor. The Kirchhoff laws now implies Ri plus 1 by Cq is equal Et. But the current I and charge Q are related. I بتساوي dq by dt. So when you substitute it here, it becomes now R times dq by dt plus 1 by cq is equal ET. Just only a very simple and straightforward linear differential equation. So we will have two types of the series circuits, LR or CR. LR, it means it has an inductor and resistor. CR, it has just only a resistor and capacitor. C. خلينا نشوف examples and how we can solve them. The example says a 12-volt battery. 12-volt battery. What does this mean? It means ET is equal to 12. Is connected to an LR series circuits in which the inductance is 5 Henry. The inductance here, what means? It means L. Here L is equal 0.5. The resistance is 10 ohms. المقاومة عندي 10 ohm. This one means what? This means R is equal 10. The question says determine the current I of t if the initial current is 0. I mean here initial current 0, it means I of 0 is equal 0. Determine the current as t goes to infinity. Right. This one here is an LR circuit. What's the equation of the LR circuits? I times di by dt it is L times di by dt plus Ri is equal E of t. Now substitute the given information only. So that becomes 0.5 di by dt plus R, which is 10I, is equal ET, which is 12. Which is 12. الآن I need to solve it. Solve it to find I of t. Okay. Now to get rid of this half, multiply both sides by 2. So it becomes di على dt plus 20I is 24, which is here linear. Which is here linear equation. هلا mu of t, so e to the power integral pt ل dt, which is e to the power integral what? 20 with respect to dt, which is e to the power 20t. Now solution I of t, 1 by mu, which is e to the power minus 20t times c plus integral. How much is f of t? Which is 12 e to the power 20t. لا 24. Sorry 24. Because here this is my question now. الآن solve this one with respect to t. A solution very straightforward. So that becomes e to the power minus 20t plus c times times c plus, sorry, على 20 e to the power 20t. So الكرنت I of t بده يساوي عندنا c في minus 20t plus 24 by 20, which is equal, divide both sides by 4 بيعطينا, which implies t is equal 6 by 5 plus c في e minus 20t. الآن I need to find the constant c. What I have to say, since I of 0 is equal 0, that means 0 is equal 6 by 5, c times 0, that means c is equal minus 60 by 5. Now substituted there becomes I of t بتساوي 6 by 5 minus 6 by 5 times e to the power minus 20t. So this is the equation and the current at any time t. هلا, this is the first part. The second part says I have to find the limit, the I of t, the time t goes to infinity. So that becomes a limit for 6 by 5 minus 6 by 5 e minus 20t, where t goes to infinity. Hello, when t goes to infinity, e to the power minus 20 goes to 0. So that becomes 6 by 5 minus 0, which is 6 by 5. Is it clear, this example?
Yes, doctor. Okay.
Any question? Any question up to now? Okay, let us see next example. The next example says a 100 volt electromotive force. Here the electromotive force, it is ET. It's 100 volt. Is applied in an RC circuits. The resistance عندنا ايش؟ R is 20. Uh, 200, sorry. 200 ohms, and the capacitance is 10 to the power minus farad. I mean here C is equal 10 to the power minus 4. The question says find the charge QT on the capacitor if Q of 0 is equal 0 and find the current IT. Type. This is for, of course, this is an RC series circuit. So it is R dq على dt plus 1 by C times Q is equal ET. So that becomes 200 times dq على dt plus 1 by 10 to the power minus 4 Q is equal 100. هلا that becomes 200 dq على dt plus 10 to the power 4 times Q is equal 100, which implies that 200 dq على dt 10 to the power 4 10 times 10 100 1000 10,000. Q is equal 100. Now divide both side by this 200. Becomes dq by dt plus 10,000 divided by 200 is equal 100 divided by 200, which means dq على dt plus 50 q. 50 q is equal half, which is here my equation becomes is a linear equation. It is a linear equation. I need to solve it. Find the mu of t, e to the power integral 50 the dt, which is e to the power 50t. هلا q of t becomes e to the power minus 50, which is t, which is 1 by e. Times c plus integral mu times f times c plus الانتجرال mu, which is e to the power 50t times half the dt. And it was just to integrate, it becomes straightforward. Q عبارة عن e to the power minus 50t في c. الانتجرال عبارة عن ايش؟ اللي هي يلا نشوف 1 by 50 times 1 times half e to the power 50t. So qt, so cpe minus 50t plus 1 by 100. Now we need to find the constant c. How? How we can find the constant c? We have a q of 0, it is equal 0 given in my question. So 0 is equal cpe minus 50t plus 1 by 100. That means c is equal minus 1 by 100. So this one here, a q of t. So c, sorry, replace it back. Minus 1 by 100 plus e to the power minus 50t plus 1 by 100. Now, second question, go back to the second part. He said find the current I of t. But I of t is equal what? I of t is equal dqo by dt. واللي هم ده تساوي 0 plus 50 by 100 e to the power minus 50t, which is equal half e to the power minus 50t. So this is I of t, which is half e to the power minus 50t. Is it clear this example؟ واضح المثال هذا؟ Any question? And Okay. Now we finished chapter 3. Chapter 3, it's already done. Now we will go to the first section of chapter. We finished chapter 2, sorry. Now we will go to chapter